Hello, today we're going to be talking about epistasis. Epistasis is basically the expression of different genes that influence a phenotype. So in this example, I have two chromosomes with different alleles expressed at different loci. So one over here and one over here. And then for this chromosome, we have one phenotype being expressed. And over at this chromosome, we have a different phenotype being expressed. What epistasis deals with is if both of these chromosomes interact, so both loci interact, and then they eventually produce either the first phenotype or the second phenotype. And this basically happens because one of these alleles, whether it's this one or this one, has a property that allows them to mask the other allele. So basically, epistasis is an interaction of two different alleles that produce one phenotype. So the epistasis that I'm going to be talking about today is duplicate recessive epistasis. Basically, if you have double A or double B recessive alleles or both, then you're going to end up with the recessive phenotype being expressed. So essentially, if you want the dominant phenotype to be expressed, then you need both loci to have a dominant allele. In this pathway here, I'm going to be using the example from Avatar: The Last Airbender, where we have people who can waterbend and people who can firebend. I'm not going to focus on earthbending and airbending. But in this example, we're going to say that waterbending is recessive. So just going to say recessive. And then we're going to say firebending is dominant. And so in this pathway, for epistasis to work, if we want to cross over here, we would need the dominant A allele to be activated. However, if we have both recessive, then this pathway is not going to work. It'll just stay as a waterbender. But then we're still at the waterbending phenotype, and to get to firebending, we need the B dominant allele to also be activated. And if we have only recessive, then again, we're just stuck at being waterbenders. So these two phenotypes are exactly the same because they both carry recessive alleles. But if we have both dominant alleles over here, then we'll end up as a firebender. Using duplicate recessive epistasis, if we did a dihybrid cross between two heterozygous individuals, we would have 9 firebenders due to the dominant alleles. And then we would have 7 waterbenders due to there being at least 2 recessive alleles. So our ratio would be 9 to 7. And then if we did another dihybrid crossover here, I already did the math, we would have a ratio of 1 to 3 due to this having at least 2 dominant alleles, especially 1, which would be fire. And then over here we have recessive, so this would be waterbenders.